Where do you get your daily dose of vitamin D? You may be thinking, what are you talking about? I get vitamin D the same place I get all my other vitamins, through my food. But this might not necessarily be true, as vitamin D is really only minimally obtained through the diet. Instead, the main source of vitamin D in our bodies is through our skin's exposure to UVB radiation, which is found in sunlight. And because of this, it may be true that Americans are becoming increasingly more deficient in this essential vitamin with time. This is because we spend most of our time inside, in houses, in our workspaces, grocery stores, etc. This deficiency could have real health implications, as vitamin D deficiency is known to cause skeletal disease, like rickets and brittle bones. However, vitamin D deficiency has also recently been associated with a variety of age-related diseases. These are things like cardiovascular disease, neurodegeneration like Alzheimer's and dementia, and more. And because of this association, it's led some to believe and to claim that vitamin D is what we call a longevity vitamin, essential for promoting healthy aging. So this is the hypothesis that I wanted to test. Is vitamin D really an essential longevity vitamin? And in order to answer this question, I turned to the model organism C. elegans. Now, C. elegans are tiny nematode worms, but you'd be surprised how similar they are to humans. In fact, many of the genetic mechanisms that govern longevity in the worms also govern longevity in humans. So my research is asking three fundamental questions. 1. Can vitamin D extend the lifespan of the C. elegans? 2. Can it extend their health span, which is the amount of time that they're healthy? And then 3. What are the genetic mechanisms behind these responses? So my first question was about if vitamin D could extend the lifespan of the C. elegans. And as it turns out, according to data we've collected in our research lab, vitamin D seems to be able to modestly extend the lifespan of the worms, which is amazing. The next questions we're currently experimenting with right now is, can it extend their health span? And we're even testing this in a strain of worms that's engineered to represent Alzheimer's disease. The final question we're investigating is, what are the genetic mechanisms that make this happen? If the genetic mechanisms that lead to lifespan extension in the worms upon treatment to vitamin D are similar to mechanisms that exist in humans, we can use these and target them as we move forward to try and treat age-related disease that's associated with vitamin D deficiency.